In item 3, we're asked to find 3 different properties that are on this process data graph for a tension test. So we have the axial stress and the vertical axis. We've got axial strain at inch per inch along the horizontal axis. The first thing we're asked to find is the proportional limit. That's the location where the stress and strain data no longer are linear. And so if we put a straight edge here at the origin and line things up somewhat by eye, we can note that somewhere in this region from here to here we begin to no longer have linear action. And so you could claim that it's right here at 50. That's probably the upper limit of an acceptable value. 44 KSI would be sort of the lower limit. So somewhere in that region of 44 to 50 KSI would be an acceptable value. When it comes to the elastic modulus that we're asked for in the second case, note that although, yes, you strictly want to use the linear elastic region, however, we don't lose any particular resolution in this case by going to this upper bound of the proportional limit. And when we do that, it turns out to be pretty convenient that the coordinate right at that location will be a value of strain. Note that we've got 1, 2, 3, 4, 5 divisions within 0.002, so that means this is 0.0004 here, so this value would be 0.0008, and that would correspond with the 50 KSI. So our E value then would be on the order of 50 KSI divided by 0.008 inch per inch. And when we do that division, then we get 62,500 KSI for Young's modulus. For the 0.2% offset method, let me put on that first data here from 44 to 50 KSI for the proportional limit. For the 0.2% offset method, remember what you want to do is go to 0.002 strain, right? So that is equivalently 0.2%, and we're going to draw a line that is at the same elastic stiffness. So that means go up to 50, go over 2 blocks, and that would give us then 2 points from which we could draw our straight line. And where that intersects our data, that would be our yield stress using this particular method. And for this one, then that would be about equal to 80 KSI.